want to go over a couple of things in last week's lab. Um, if I have a rectangle of length times width, and I want to know the area of it, of course area is approximately length bar times W bar. That'll be our average measured area. But let's look at another thing here. We'll have a delta W here, say we'll call it delta W, and we'll call this length over here delta L. So we've got these two areas as the kind of the uncertainty in the area. And to find the actual uncertainty, we're going to take this rectangle, which has, let's call this area 1, and this rectangle that is area 2, and area 1 is the width times delta L, and area 2 is L times delta W. And the uncertainty in the area, so we'll just kind of write it as dA is equal to, well, it's kind of the Pythagorean theorem. dA squared equals a1 squared plus a2 squared. So it's the area of this the uncertainty in A is equal to the uncertainty in A1 squared plus the uncertainty in A2 squared. And so our final result would be dA equals square root of A1 squared plus A2 squared, where A1 is W delta L and A2 is L delta W. So how would I do this on a spreadsheet program? Well, let's say we have these 12 measurements, and I'll count those for the length and the width. So we'll say the mean, the standard deviation, and the standard error of each of these things. And we'll say this is equal to the average of all of these things. The next one is equal to the standard deviation dot S, parentheses, of all of these things. And then the standard error is equal to the standard deviation divided by the square root of, in this case, it's 12, because there's 12 objects up there. So then we can just copy that over, because this will be the average of those things. This will be the average, or the standard deviation of these things, and this will be the item above it, just divided by the square root of 12. Okay, so now I'm going to think in terms of LDW and WDL. So we just want two of these, one for the standard deviation and one for the standard error. So this is going to be equal to the mean length times the standard deviation of the width, and this will be the mean width times the standard deviation of the length. Same thing here. You don't want to copy this down because of the cross nature of it. So this is equal to the mean length times the standard error of the width, and this one is equal to the mean width times the standard error of the length. So, so this will be the standard error of the standard deviation of the area, and the standard error of the area is going to be equal to the square root of this squared plus this squared, and that's the standard deviation of the area. And then that can be copied down because it'll just be using this squared plus this squared. Another trick that might be of interest is, how do we find out which of these lengths is within the standard error of the mean? And so I'll show you a couple of tricks. One is to do a conditional formatting. Watch this. I'm going to grab all of these. I'm going to do conditional formatting, and I'm going to do highlight cells rule and select between, and I'm going to select cells that are between the mean minus the standard deviation, and then up on the above side they're going to be between the mean plus the standard deviation, and I put an equal sign in there, and those are going to be filled with light red fill with dark red text. And now it shows me which ones are in between the mean plus and the mean minus the standard deviation. Another way I can do that is to think in terms of, or if I go equals, I want to take this length minus the mean and divide it by the standard deviation. Now the mean is at a specific location, so I'm going to mark that with dollar signs. And the standard deviation is also in a specific location, so I'm going to mark it with dollar signs. And watch what happens here. Okay, with that formula, by subtracting the mean and dividing by the standard deviation, this tells me exactly how many standard deviations this data point is from the mean. So this data point is 0.819 standard deviations below the mean. This data point is 1.5, or this data point is 1.59 standard deviations above the mean. And you can see wherever we have a 0 over here, we're highlighted in red over here. So anything that is 1 or more standard deviations away from the mean, we have non-highlighted over there. So here we have 1, 2, 3, 4, 5, 6, 7 data points that are within 1 standard deviation of the mean. The rest of this video is going to be redundant. I'm just going to do that again with these other data points. So once again, select that, conditional format, highlight cell rule, between, and we will use the mean minus the standard deviation, and they got 61 there, I don't know what that is, equals the mean plus standard deviation. And once again, those are our numbers. And if we want to do figure it out by looking at figure out exactly how far that data point is from the mean in terms of standard deviations, this will be equals that minus the mean, parentheses, divided by the standard deviation. But once again, for the mean, we have to put in those dollar signs. For the standard deviation, we have to put in those dollar signs. copy that down, and every one of these formulas, since we use the dollar signs, we'll be referencing those two quantities. And everywhere where we have a number more than 1 away from the standard deviation, we get a non-highlighted number. And the number that, or the percentage-wise, this is going to be 7 out of 12, and this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, equals 9 out of 12. And let me recount this because 1, 2, 3, 4, 5, 6, 7, yeah. So 58% of these are within 1 standard deviation of the mean, and 75% of these are within 1 standard deviation of the mean.